गेला असेल. तेच म्हणलं मग दोघं दोघं काय करतात समजा ते आज माघार येतात का पुढे गावाकडे तुम्ही आज जाऊन या उद्या परवा दिवशी मी जाते.
पाटील सर. हॅलो पाटील सर.
हा येस सर.
लोअर सर जॉईन झालेले आहेत, दुसरे जे ढोकळे सर काही अवेलेबल नाही आहेत. आपण सुरू करूया.
लॉर्ड सर आणि फुलसागर सर आहेत का?
फुलसागर सर पाहतो मी.
हो.
सर फुलसागर सर जॉईन होतील का?
सर आपण स्टार्ट करू, अनाऊन्स करू त्यांचं नाव सगळ्यांचे, स्टार्ट करू, ते जॉईन होतील नंतर.
Good morning, sir.
Good morning.
Actually, sir, I have registered for the participation, but my name is not in the list. So, can I present today my presentation?
In which subject?
Have you registered?
In chemistry, sir. Yes, I have registered.
You have sent your paper for online or offline mode?
Online.
Online, sir.
So then you can present. If you have sent the paper, if you are registered, now you can present, no problem.
Okay, sir. Thank you so much.
We will call, then you will share your.
Yes, sir. Yes, sir.
We'll call one by one.
Okay, sir.
Hello, Kulkarni sir. Hello.
Sir.
Can we start now?
दुसरे कोणी फुलसागर पण नाही आहेत आणि ढोकळे आहेत.
नाही सर, आपलं आपण हे चालू करूया.
ठीक आहे काय हरकत नाही, चलो. पाटील सर.
मला बसवलं हे कोणतेच कोणते.
पाटील सर थांबा, चालू करा तिकडे. Hello, Patil sir.
Start.
Yes, start kara sir.
Yes, yes, sir. Good morning to all the dignitaries, participants, and attendants of this program. Let me have an opportunity to introduce myself. I am Dr. Narendra Ji Patil from College of Engineering, Ambadogai. I take it to be the immense pleasure to coordinate this event. As you all know, we are here to participate in the online conference on advanced nano research and applications on behalf of Shrikrishna Mahavidyalaya Gunjoti. I welcome to the chairperson for today's event, Professor Dr. K.S. Lohar sir, Department of Chemistry, Shrikrishna Mahavidyalaya Gunjoti. I also welcome the examiners, Dr. S.S. Fulsagar sir, Department of Mathematics, RP College, Dharashiv, and Dr. Dhokare sir, Department of Chemistry, Arts, Commerce, Science College of Nazru. I also welcome all the resource person going to present their research paper. Hope we get a good discussion and quality research in the field. Please note that the time to present paper will be 7 minutes and 2 minutes for question and answer session. All the participants are asked to be ready to connect to avoid any technical issues. Now, I invite P.D. Masay sir to present his paper.
Masay sir, are you here?
Masay sir, are you ready? Next participant OP38 number, Apeksha Maru.
Okay, sir.
Yes, you can share and start presentation.
Is it visible, sir?
Yes, yes, visible, visible.
Okay.
Hello, excuse me. What is your paper code number? OP presentation?
38, sir.
38. Okay, thank you. Please introduce yourself and give.
Sorry, sir.
Please introduce yourself and
Yes.
give.
Okay. Yes, sir. Good morning, everyone. Myself Apeksha Maru. I am doing PhD from Department of Physics, Maharashtra University. So today's my presentation is on role of 200 MeV plus 15 swift heavy ion radiation induced defects across mixed-well and manganites-based thin films. Here it is the plan of presentation, which includes introduction, experimental details, result and discussion, and conclusion. So this is the very brief introduction about the manganites, which is a BO3 type perovskite structure having general formula that is R1-X AXMNO3, in which R is the rare earth metal, that is La3 plus, Gt3 plus, Y3 plus, etc. And A is the alkali metal, that is calcium, strontium, etc. The basic properties exhibited by manganites are Jahn-Teller distortion, Zener double exchange mechanism, charge ordering, and orbital ordering. So this is the experimental method or synthesis method that has been used to prepare LGCMO, that is LAGDCMNO3, Al2O3 thin film. So the LGCMO film were grown over 001 oriented Al2O3 single crystal and substrate by using PLD technique. The 248 KRF laser with the 240 nanometer wavelength having 200 mJ per centimeter square energy at 5 Hz repetition rate for ablation of LGCMO target, for which the substrate temperature was employed, that is 750 degrees Celsius, with the oxygen partial pressure of 350 milliliter, and the target and substrate distance was between 5.5 centimeter with the deposition time of 29 minutes. All the this prepared film was then irradiated using 5 into 10 raised to 11 ions per centimeter square and the 5 into 10 raised to 12 ions per centimeter square. The code is given, that is LGCMO pristine, LGCMO 11, and LGCMO 12. So the results and discussion. The figure at the left hand side shows the structural property that is obtained by X-ray diffraction method. From the graph, we can see that all the film possess single phasic nature without any detectable impurity within the measurement range employed. From the graph, it is clearly see that there exists a visible separation between the XRD peaks of film and substrate at the measurement range of 42 to theta range. So to know the latest mismatch between the film and substrate, that can be calculated using the strength formula, that is D film minus D substrate divided by D substrate. And from this formula, I have obtained the strain value, which is increasing upon irradiation from pristine to irradiated thin films. In this negative sign shows there exists a compressive strain between the film and substrate. Now, the graph B shows the microstructural property that has been characterized using atomic force microscopy. And from this graph A, B, and C, we can see that there exists a island-like structure of the grains. And upon irradiation, these grains becomes more sharp and distinct. The graph G, H, and I shows the grain size which has been calculated using the atomic force microscopy. And from these three graphs, we can clearly see that the value of the grains size decreases upon irradiation. That might be due to the irradiation induced local heating as they imparts some part of its energy onto the surface, and that is why the grain size is decreases. And this graph J, K, and L shows the RMS roughness that has been calculated from the atomic force microscopy, and from this we can see that upon irradiation increase. That is due to the higher fluency employed. So this is the frequency dependent electrical properties. Sorry, sir. Hello.
Hello, you can continue, ma'am.
Okay, sir. This is a frequency dependent electrical properties that is reactance, resistance, and impedance. The graph A shows the measurement of the reactance versus frequency up to the frequency range of 10 kilohertz to 2 megahertz. And from this graph, we can see that the value of the reactance is found to be increased with applied frequency. That is due to, from this we can see that there exists an inductive nature. And upon pristine to irradiated films, we can see that the value of the reactances increases. And this graph B shows the resistance versus frequency. And from this graph, we can see that by increasing the frequency, value of the resistance is found to be decreased. That is due to the electric field induced movement of about the from pristine to irradiated thin films, that is LCMO pristine to LGCMO12, the overall value of the resistance is found to be increased. That is due to the defects induced by the higher irradiation, and the value of the strain is also increased, that we have discussed from the atomic force microscopy roughness graph. The graph C shows the impedance versus frequency. From this graph, we can see that the value of the impedance is found to be decreased with respect to applied frequency. And in the lower frequency region, the impedance value is higher. That is due to the accumulation of the charge carriers at the lower frequency region. And the overall value of the impedance is found to be increased upon irradiation. That is due to the defects and the strain due to higher fluency. So these plot so these are the Cole-Cole plots and the ANC plots. From the Cole-Cole plots, we can get to know about the role of the grains and grain boundary for the electrical properties. And from this graph, we can say that from LGCMO pristine to LGCMO12, we are obtaining the large semicircle. So that we can say that there is an effective role of the grain boundary at the electrical properties. And this is the ANC, that is average normalized change in impedance with respect to applied frequency. From this, we can know the key role between the grain boundaries and the grains. And from this graph, it is seen that the value of the ANC is found to be decreased with respect to applied frequency, which is the characteristic of the any electrical polarizability of the material. From the graph, we can see that the grain boundaries and grain plays their significant roles in governing the electrical properties, whereas competitive effects of grain boundaries and grain can be realized at intermediate frequency region. And from this, we can see that there exists a sharp change at the higher frequency and lower frequency region, that ANC is sharply decreasing, so that it can be calculated at the intermediate frequency region, where ANC varies insignificantly with frequency. For the different current employed, that is 1 microampere, 2 microampere, and 3 microampere. From this, we can see that the value of the temperature that is increasing, the value of the resistance is decreasing for all the graphs under study. From this, we can see that all the prepared samples possesses semiconducting nature. And from this graph, by increasing the value of the current, we can clearly see that this value of the TP is shifting towards room temperature. And the overall value of the resistance is found to be decreased with respect to applied temperature. That is due to that at the higher temperature range, the charge carrier gets thermal energy, and that can effectively contribute into the conduction process. This experimental data can also be understood in terms of the theoretical measurement. In this graph, all the data has been fitted using the variable range hopping, that is VRH model, with the formula rho is equals to rho 0 exponential T0 by T raised to 1/4, in which the rho 0 is the constant and T0 is the characteristic temperature. From the variable range hopping model, we can get to know about the activation energy. By this, I have obtained the activation energy, and from this graph, the activation energy for each graph is found to be increased from pristine to LGCM11 films. That is due to the strain created due to higher effluency. These are the conclusions. Thank you.
Madam, I have one question. Okay, you listening me?
Yes, sir.
You plot a graph from resistivity readings.
Yes.
You there mention activation energy.
Yes, sir.
What is the use of our applications of activation energy? Can you tell something about it?
Basically, sir, activation energy is the energy that is required for charge carriers to overcome the barrier height.
Okay.
So from this, we can get to know the possible applications from which whether the activation energy higher or lower.
Hmm. Okay. You are PhD student?
Yes, sir.
Okay. Somebody have any questions regarding this presentation? Please ask. Okay, thank you, madam. Who is the next presenter?
Okay, thank you, sir.
So next,
Next participant, code number OP39, NA Chongar.
ના હજી કેતો ને હવે એનો આવશે જીમિત્રી.
OP39.
OP39.
Pramod Muse, are you ready? Pramod Muse,
Yes, sir.
can you present now?
Yes, sir. Yes, sir.
Yes, you go ahead.
Okay, sir.
Pramod Mase, you introduce yourself.
Yes, sir.
Share screen and start.
Wait a minute, sir. I am just start presentation.
Hello, Pramod. What is your
OP30, OP35. One minute, sir.
Pramod,
Yes, sir. I'm just sharing my screen, sir.
share your screen.
Okay. Is it visible, sir?
Is visible.
Okay, sir. Myself, Pramod Mase. I'm a research scholar doing PhD under the guidance of Dr. S. Pathange, sir, Shrikrishna Mahavidyalaya, Gunjoti. My research topic is today a review of recent research on the application of multifunctional composite materials with the different properties. So I'm skipping with the abstract. So when we're talking about the material history about the different materials, so first the composite material first used in the 1500 BC when Egyptian used the mixture of the mud and straw which create the strong buildings at that time with the mud and the straw. After that, in 1200 decades, the Mongols invented the first composite bow, which for which the material used, which is the bone and wood and the animal glue. Then after that, in 1900th century, the plastics and such as the polystyrene, different polyester, the materials are developed. And after that, in 1935, the fiber glass, first glass fiber was introduced in the field of the industry, in which the fiber reinforced polymers are take part in the industry. So then when we talk about the composite material, so there are some reasons to use the composite materials in our day-to-day life. So first of all, these materials we use because of these kinds of materials are make the modern life very easy. Because most of the materials we used in day-to-day life are made from the composite materials. They are having the physical, chemical, and biological properties which are different, make them different from each other. These materials are achieve the highest level of efficiency when we made these composite materials, and we used in the engineering applications. So the main purpose of using the composite materials, because these materials having the two and more materials to mix together to make the composites. So it used to improve the property of different materials. So apart from this, as we used in day-to-day life, there are different materials that are used from the prepared from the wood and the different materials. So when we use the composite materials, it having some basic properties. As we talk about the disposition, durability, resistance, then their design possibilities. There
Mr.
are,
Pramod,
yes,
Mr.
sir.
Pramod, you show what you have done, your work. You show your work, what you have done.
Actually, I'm just presenting over here the different applications that are used from the composites.
Have you
It's
tested these applications?
yes, sir.
Have you tested your compounds for these
No,
applications?
sir. No, sir. I am just working on
Then
this
just
material.
you
Hello.
briefly mention and go to your work.
I'm just presenting just a review of this material, sir. My work is going on still. It's not directly my analysis is not available to present right now.
Then
I'm just
how you can say that this is your presentation?
sir, I'm just presenting the review of the composite material. What kind of the work has been done?
This is not expected. What is expected is what you have done, that is to be presented.
Okay, sir. In this presentation, I'm just presenting the review of the material, wherever the composite is used.
That is not required. Whatever you have done up till now, that you can mention, that you can show here. You go briefly about history and go to your real work that you have done.
Okay, sir. Currently,
I think you does not done any experiment. You only give review of literature. Okay.
Yes, sir. Yes, sir.
Please stop your presentation. We
Okay,
call
sir.
next.
Okay, sir. Okay, sir.
Okay.
Who is the next presenter?
Next presenter, Bharvi Hirappa, OP32.
Yes, he is here. Hirappa, Bharvi Hirappa. Can you hear us? Hirappa.
Yes, sir. Yes, sir. Yes, sir. I'm here. I'm
Bharvi.
present. Yes, sir.
You share your screen and
Yes, sir.
start presenting.
Yeah.
Yes. Introduce yourself. Share screen.
Sir,
Yes.
myself, Bharvi Herpara, and I'm pursuing PhD at Saurashtra University, Rajkot, under the guidance of Professor Nikesh Shah. And here is my presentation. Is it visible, sir?
Yes, visible. Go ahead.
Yeah. So I'm working on YMNO3 based mixed valent manganite compounds. Here I'm presenting a brief part of that. So this is my plan of presentation. Is it changing? No? Yeah. Yeah. So shortly, YMNO3 manganites have been used widely for memristive and resistive switching kind of applications. Here, because of the main viewpoint, that is they are showing very speedily ferroelectric and antiferromagnetic transitions, and with a little bit of perturbations in kind of their properties. And here I have studied 10% doping based YMNO3 compounds at Y site. The samples have been prepared by using the oxides of those by the solid state reaction route method by consecutive sintering, calcination and then sintering and then final pooling and obtaining the samples in the pallet form of 20 for the target of for the use of being used as target PLD targets. The samples have been prepared at UGC DI BRNS laboratory at BARC Mumbai. Uh, the samples have been characterized first for the structural conformation by X-ray diffraction method. The X-ray diffraction method here here shows here the single phase for YMO and YSMO samples, and as you can see here, around between 30 to 40 degrees, we can see dual phase in the middle blue colored YCMO samples. And the dual phase exists for two kind of structures, orthorhombic and hexagonal. For the confirmation of that, we have gone through ritual refinement of the samples. The ritual refinement here the A is the YMO, B is the YCMO, and C is the YSMO sample. We can see here that there is a fine and clear matching observed between the calculated data as well as the observed data via ritual refinement. We have used Python-based GSS2 software for the Lorentzian and Gaussian functions, which have been verified to match. And also the residuals of the fits have been shown by the black line, that is delta by sigma ratio. And we have also shown the Vesta generated structures for diagrammatic representation of the structures. The structure have been imaginarily made in Vesta. Now we have obtained some structural parameters from the ritual refinement method. From that we can see here that this is a structural phase. YCMO shows two kind of phases, that is hexagonal and orthorhombic. 41% of the hexagonal and 59% of 59% of orthorhombic phase. And showing the PBNM space group as well as the P63CM phase group number 185. Also, from the cell parameters and the cell volume, we can see that the by doping of 10% of doping at the yttrium site, we see that the yttrium structure gets disturbed for the right now talking for the hexagonal phase, and the cell parameters, that is A, B, and C decrease, well as the cell volume also decreases for as we go for the doping. This is based on the average A site cationic radius, that is also shown in the last second row of the there. Average cationic ion radius increases from YMO to YCMO to YSMO, and due to that, because of the larger ionic radii of the dopants, that is calcium and strontium doped at the yttrium site. Also, we can see that the average crystallite size of the YMO is the largest, then YCMO, and then YSMO. It consecutively decreases also due to the substitution of larger cations, that is structural disorders come in picture, which reduces our stresses in the material and leading to Jahn-Teller deformation, and some creation of oxygen disorder and vacancies. And also we can see that is reflected from the oxygen content value, that is oxygen content also loss is also seen from YMO to YCMO to YSMO compound. Also we can see that at A site, the disorder created is larger for the case of YSMO, that is almost 5 times larger than the YCMO because of the larger ionic size of the strontium ion, that is 1.32 angstrom as compared to 1.05 angstrom in the YCMO side. And this is also we can take a note of it, that is almost only for 10% doping we are seeing so much of kind of differences in structural property, which is also the reason of studying YMO for different kind of applications. Now going to the dielectric characterization properties of the material. Here we have seen that the dielectric constant is shown with variation in dielectric constant with frequency is shown. There is a reduction in dielectric constant for all the samples as frequencies increases, and this can be we can ascribe this to the field induced enhancement in dipole relaxation. That is, the response of dipoles becomes weak at higher frequencies, and which leads to suppression in the capacitance of the material. Also, we can see here that the dielectric constant of YMO is found to be lower, and because of the presence of A-site disorder within the lattices of doped manganese due to ionic size mismatch between yttrium and divalent dopant ions. Is also we can here see highlightly that for the YCMO sample, hexagonal structure supports non-centrosymmetry, and which favors the ferroelectricity in our material exhibited by the hexagonal structured manganites. So in this context, we can say that YCMO should exhibit lower dielectric, since YCMO structure possesses dominant orthorhombic phase, which is that is 59% as seen in the ritual refinement, and which is not favorable for non-centrosymmetric nature, so ferroelectricity as well as high dielectric. But our present study indicates some opposite nature of dielectric constant values, where YCMO exhibits larger dielectric constant as compared to YSMO. This we can this is because of the average crystallite size, which is efficiently larger for YCMO as compared to YSMO. As a result, we expect better electrical polarization across the YCMO and which contains large number of crystallite boundaries having stronger crystal imperfections, as also that is also confirmed by the ritual refinement studies, that is crystallite size has been is larger for the YMO than YCMO and YSMO. Also, in addition, we can see that the stronger A-site disorder is seen in YSMO compared to YCMO, that produce better structural deformation, hence supports non-centrosymmetry. And also we can see here, to understand the dipole relaxation mechanism, we have shown the collicular relaxation mechanism has been fitted, as shown here by the mentioned by the equation below. And from that, alpha is found to be get enhanced from the value for the upon doping of SR2 plus, where it gets suppressed for the case of YCMO. So sequential reduction in tau time also is also seen, and so we can see that in the tau, that is the relaxation time, is also seen, and hence dielectric constant can be understood from is understood to be enhanced from YMO to YCMO to YMO to YSMO to YCMO. Also, now we have understood the conductivity properties. From that, we can see that the frequency dependence of AC conductivity is shown here. We can observe that enhancement in AC conductivity with increase in frequency. This can be understood as when AC electric field is applied, free charge carriers obtain higher energy, thereby pass across sample lattices and provide improved conduction across lattices. And the better conduction can be seen due to we can say that due to the doping of divalent cations at Y site, which results in transformation of manganese ion valence state from +3 to +4, which helps in Zener double exchange mechanism based lattice, and that is the reason for the improvised conduction. Also, larger values of AC conductivity is seen for YSMO as compared to YSMO compound, which can be ascribed to the lower size disorder that supports better charge conduction across the manganite lattices. Also, here we have fitted Johnson's power law for the material. Sorry, the equation has been mentioned, has been left out to mention, that is sigma AC is equal to sigma DC plus A raised to omega n, where A is the prefactor of the system, eta is the power exponent. And from that, Johnson's power law fittings, we can say that the YMO and YSMO compounds experience single nature of charge conduction through the frequency range, which can be ascribed to single nature charge conduction across the single phase lattices. Whereas for YCMO manganite compounds, two different conduction mechanisms have been seen. As we can see, Johnson's power law fits in two different regions, and that one at lower frequency region, well below 350 kilohertz, and other above the same, right? So interestingly, we can see that obtained 4 different values of eta for all the samples can be found lower than the unity, which indicates the presence of correlated barrier hopping mechanism for the charge conduction process. Also here, we can see that two different charge conduction mechanisms within the YCMO manganite lattice may be ascribed to the presence of dual crystalline phase of YCMO mixed iron manganite. That is also seen in the ritual refinement, that is hexagonal and orthorhombic phases, which leads to dual two values of fitting here. And YCMO also, we can see that YMO possesses larger crystallite size, whereas YCMO has a smaller crystallite size as compared to YMO, and larger crystallite size as compared to YSMO compound. So the ground state of all the samples is in semiconductor at room temperature. The core of the crystallite is experiencing semiconducting nature. So YCMO possesses comparatively lower size disorder as compared to YSMO, and YMO has no possibility of Mn plus 4 ion. Thereby, it is difficult to have Mn3 plus to O2 to Mn4 lattice formation, whereas better assisted Zener double exchange lattice can be realized for YCMO compound as compared to YSMO. So that is the reason. Now we have the impedance properties also. Here, impedance shows the variation in impedance with frequency for all the three compounds. For all the three samples, impedance is found to decrease with increase in frequency, which can be ascribed to the field-induced enhancement in energy attained by charge carriers, thereby conduction gets enhanced and resistance part of the impedance for all the three samples gets suppressed. Yes, ma'am. Yes, sir.
Please conclude. You are taking much time. Please conclude.
Yeah. Okay. Yes, sir. Yes, sir. Yeah. Then we have the transport properties also we have studied, that is IV characteristics of YCMO. The room temperature IV clearly shows the non-linear nature of charge transfer mechanism, and YCMO experiences much larger current compared to the current drawn from the YCMO compound. So from this, we can conclude that the ICMO compound can be used for the better conduction applications wherever is needed, and YSMO compounds can be used with there is an application of a higher resistance material is needed. Okay, thank you.
Okay, thanks.
Hello.
Any questions?
One questions.
Yes, sir.
You prepare the sample analyzed by XRD, and after that you analyze by ritual refinement method. Okay.
Yeah, yes, sir.
After ritual refinement method, you give some values. There is
Yes,
one is chi-square, or it may be say chi. Okay.
yes, sir.
Which is the ideal value for chi?
Sir, it should be around 1, no?
Why?
Sir, because chi this chi-square is showing the what say value. It is the difference in the observed and calculated data. So goodness of fit also should be around 1. That is that which shows the proper matching between the observed and calculated values.
Which value I think standard value. Okay.
Yes,
In
sir.
your discussion, you say with addition of doping, there are some distortions are to be observed. Okay.
Yes, sir.
Due to some distortion, which property improved?
Exactly. I did not get your question. Can you please repeat, sir?
You take a magnetite as a mother sample. Okay, in which
Yes.
you add dopant.
Yeah.
Okay. After addition of dopant, the initial properties of MnO3 are mother sample, which to be distorted.
Yes.
Due to distortion of a structure,
Yes,
which
sir.
you expect to be improved.
Yes. Okay, so that is the question. What properties I need I'm looking for, right?
As compared to the initial compound.
Yeah. Yes, sir. Actually, why I was looking for some improvisation in its as a memory storage device. So I've been doping this at yttrium site for a relative change in its mainly the transport properties. But since it is necessary to verify the dielectric study properties also, I have gone through those dielectric and conductivity properties. Mainly, I was looking for improvisation in the memory window of the material, and that I have already obtained, and that has been published as article in Material Study Communication just recently before 2 months only. So that was the main part. This is my some side study for dielectric and conductivity properties to confirm the structure.
Okay, thank you.
Yeah, you're welcome.
Okay, thank you. Nice presentation.
Thank you, sir. Should I stop sharing, or are there any
Yes.
question?
Yes, you can stop. Who is the next participant?
Okay.
Thank
Hello.
you. Next participant, I invite Nisarga Rawal,
Yes, sir.
OP14.
Yes.
Yes, sir. I'm here. Good morning, sir.
Just you
OP40.
introduce yourself.
Okay.
Say and start.
Okay, yes, sir. Yes, sir. Is my slide visible?
What is your presentation number?
Sir, it is OP40.
Okay.
Sir, is the screen visible?
Visible, you can start.
Okay. Good morning, one and all present here. My name is Nisar Raval. I'm from Department of Physics, Maharashtra University. Today, I'm going to present about the NN junction-based semiconducting CDO LCMO storage studies for RERAM applications. Now, I think it is not changing. Okay, yeah. Now, what is RERAM? RERAM means resistive random access memory. RERAM is a non-volatile memory. That means that if we turn off the power, then also the data will remain intact. So that can be used in the hard disks, CD-ROMs, and all those things. The right-hand side, you can see the schematic diagram of the resistive RAM, which contains two electrodes, top electrode and bottom electrode, and in between that, the memory cell is there. Now, generally, these memory cells are made up of many of metal oxides. Below that, you can see the array or the matrix of the memory cells combined together. Now, this graph shows the ideal IV characteristics of resistive RAM devices. Now in there you can see that there should be a set mechanism and reset mechanism. That means that it shows two resistance values, high resistive state and low resistive state, which can be which can decide the zero state or one state in computer applications. So motivation to study manganite based REM, because manganites, which is a perovskite structure, it is having many degrees of freedom, like charge, spin, lattice, and orbital. So it is very sensitive towards external factors applied to that. And also it is having partially filled EG orbitals, which is behaving as the active orbital for showing these properties. These are my sample details. So I have prepared here NN junction. Uh, we have used L203 substrate onto which I have deposited LCMO. The stoichiometry is that La.3, Ca.7, MnO3, and onto that I have deposited another CDO layer. The thickness is given here. CDO is kept fixed 50 nanometer, and the LCMO layer we are changing the thickness 150 nanometer, 200 nanometer, and 100 nanometer. According to that, the sample code are given. So 100 nanometer LCMO means C10, 150 means C15, and for 200 nanometer it is C20. Below that you can see the device geometry for transport measurements. This geometry we have used for taking all the measurements. So one electrode will be kept on CDO and another will be kept on the LCMO. So both the layers will be behaving as the active layers. This is the synthesis of this LCMO film. So onto the L203 substrate, we are depositing LCMO substrate using the spin coater method by using sol gel technique. So for sol gel, we have used the acetates of calcium, lanthanum, and manganese acetate in proportionate manner into the solution of acetic acid and double distilled water. Now this solution will be used for the spin coating the LCMO layer onto the L203 substrate. Then we have done the annealing at 900 degrees Celsius for 24 hours. Now on this LCMO layer, we will deposit another CDO layer by the same manner. Just we will use the cadmium acetate as the precursor. This is the XRD structural characterization. From XRD, we can see that the crystallite size is first increasing for C15 and then decreasing for C20. Now the microstain values are also given here, dislocation density, and all these things, all these parameters have been calculated from the XRD only. This is the microstructural characterization by using AFM. So here we can see that for the first column shows C10, second shows C15, the third one shows the C20. Here we can see that by increasing the thickness of the manganite layer, the grain size is increasing from 310 nanometer, 376 nanometer, and 432 nanometer. The average RMS roughness size is getting decreased for 10.56, 6 to 5 nanometer average. This is the general phase diagram shown by such kind of LCMO manganite. So here for my study, I have used La.3 and Ca.7. So if we go for X is equal to 0.7, we can see that around 250 Kelvin, we will get a transition of charge ordering. So in the room temperature, my sample will be paramagnetic insulator. Now around 250, it should go it should show a transition to charge order state, and below that again it should go towards the AFM, means antiferromagnetic transition. Now what is charge ordering? Here this you can see this chessboard like pattern. So the Mn, there will be arrangement of Mn3 plus and Mn4 plus in periodic manner. So there will be a charge poor region and charge rich region in periodic manner. So that is known as the charge ordering state. Now this is the temperature dependent resistivity. Here we can see that it is showing the semiconducting like behavior. So the resistivity is getting decreased with increasing temperature, and for all the thickness, if we increase the thickness, the resistivity is getting decreased. So in Roti measurement, we can see here that near in the window of 250 Kelvin to 300 Kelvin, we are getting the charge ordering transition for all the samples, and TN transition means it is going towards antiferromagnetic transition at lower temperature for all the thickness of thin films. We have fitted the mod type VRH model, and all these parameters have been calculated from that. This also shows that from that we have calculated hopping distance, average hopping distance, and average hopping energy in the variation of temperature. Now the main characteristic, which is REM based measurement, we have done the hysteretic IV characterization for temperature dependency. So we can see that starting from 233 Kelvin, which is lower temperature, we are going towards from lower temperature to high temperature. We can see that it is showing a window. So it is showing a very good window, and also it is showing the set and reset mechanism. The set and reset voltage are calculated for forward bias and reverse bias both, which can be seen on the screen. Now, if we increase the temperature, we can see that the set and reset voltage getting decreased towards the origin. So if set and reset voltage is getting decreased, and window is also getting better and better with increasing temperature. The current value, if we observe, the current value is getting decreased. So for 273 Kelvin, again we can see that set reset voltage is getting decreased again. This is for 293 Kelvin. The current value is in microampere. You can observe here for 313 Kelvin. And this graph shows for all the temperature variation together. So we can see that for 313 Kelvin, the current is highest, and for lower temperature, the current is lowest. So this shows that semiconducting behavior. Now, what is happening? Why we are getting such kind of window? So this window is, as it is showing two resistive set, lower resistive set and higher resistive set, which behaves as 0 and 1. So the mechanism here is that if we apply enough voltage, so between CDO and LCMO layer, there is a depletion region. So as both the layer are N type, it is having some kind of barrier. So we have to give excess energy for that barrier. So as it is getting enough voltage, so it will be set, and this kind of conducting filamentary path are getting formed. So it will give us the enhancement in current. So the set voltage is there. And if we decrease the current in reverse manner, so this conducting path is again getting disturbed, and it is getting disconnected. So again, we are getting the lower state of the same. So this is the set and reset mechanism we can understand on this basic model. Again, I have studied resistance state and time. So by giving it a lot of time, we can see that resistance is getting almost constant. It is staying constant, which is necessary for such kind of resistive RAM devices. For lower temperature, it is unstable. But again, at higher temperature, if we go, the resistance state is getting stable and stable. So it is good for our resistive RAM applications. We have calculated the power consumption for these devices for lower resistive state and higher resistive state both. So here we can see that power consumption is in microwatt range. So it is very much low power consumption, we can say. So it is useful for practical application. And again, going towards a higher temperature, we can see that at room temperature, the power consumption is getting lower and lower. So it is beneficial for us to use in the actual practical applications. And these are the LRS and HRS values of power consumption by variation of temperature in this graph it is shown here. So that's all from my side, and I thank Good Coach for providing financial assistance in form of major research project, and thank you so much.
Okay, thank you. Are there any questions from the participants? Lower, sir.
Sir, which are the main applications of your compound?
Yes, sir. Main application, as I already told, that this is an N junction device, so it can be used in resistive RAM applications. We can see that there is RAM inside our computer. RAM and ROM, two things are there, which is used for storage of information. So this compound NN junction I have prepared, it can be used for resistive RAM. So it can be used in non-volatile memories for storing zeros and ones of data inside our material.
Okay. Have you tried these compounds on commercial scale?
No, sir. Actually, just for I was just prepared and characterized these thin films. So it is rightly at laboratory level only. So I am thinking to go towards patenting and commercialization in the future.
Yes, yes. Because your work is good one. So it
Yes, sir.
you should go for commercial applications.
Definitely, sir. I am thinking.
Benefit of the
Yes, I'm
concept.
thinking for filing a patent onto this this thin film.
Yes.
So yes, thank you, sir. Thank you for suggestion.
Thank you. Thank you. Nice presentation.
Thank you so much, sir. I hope I am in time. I have ended in time. So thank you so much, sir.
Thank you. Next presenter, I invite Yeni Chongar to present his paper, OP39. Are you ready?
OP39.
Next presenter, Ajay Patil, OP41.
Ajay Patil. Any?
Next, Reshma B. Bhosle, OP42.
Yes, sir.
Yes. You introduce yourself.
Go ahead.
Screen share and
Yes, sir.
start your presentation.
Okay, sir.
Are you presenting from mobile?
Yes, sir. Sir, there is a problem of my laptop. Sound.
Okay, okay. Be careful because sometimes mobile may make trouble. So be careful. Okay, go ahead. No problem.
Good afternoon, sir. Am I audible, sir? Sir?
Yes, you are audible.
Yes.
First of all, my title of this paper presentation is the synthesis and characterization of the aluminum dope nano ferrites by using Solgel method. Myself, Reshma Bhosle, research scholar from the Department of Chemistry, Dr. Babasaheb Ambedkar, Subcampus, Dharashiv. Key points: introduction, synthesis, characterization, result and discussion, application, and then conclusion. First of all, we see that introduction. Nanoscience is one of the most important research and development frontiers in modern science, including preparation, characterization, and synthetic applications of nanoparticles due to their high surface area and unique size-dependent properties. According to the field of metal nanoparticle catalysis should offer opportunities for new chemical reactions. In review of literature, few work on supported catalyst has been done. Therefore, here is need to extend this research work with their catalytic studies. Thus, this is a scientific challenge, economical and ecological relevance. There are several methods.
Excuse me, don't read all these things. Just you highlight and go to the results. Just you highlight the synthesis, everything, and discuss the results in detail. Okay, continue.
The synthesis, taking a mixture of all nitrates of aluminum, lanthanum, cobalt in distilled water on the hot plate and then add the equimolar concentration of citric acid. Then the solution becomes pink colored and gel form. Then the gel was completely dried with the next 3-4 hours. And this raw powder was calcined at 1000 degrees Celsius for 2 hours to get the pure nanomaterial ferrites. Then characterization. First of all, we see UV visible spectroscopy. From this graph, left side graph, it has been shown that the lambda max of this, that is the maximum absorption of these ferrites at 265 nanometers, and the optical band gap energy of this material is decreases as the concentration of doping element aluminum is increases. Then XRD, that is X-ray diffraction study. From this XRD, it has been observed that the nature of this material is the crystalline in nature, and the particle size was calculated by using the Debye-Sherrod equation is found to be 19 to 27 nanometer, and from the HKL values, it shows the FCC structure. Then scanning electron microscopy. From this graph, it has shown that the particles were spherical in nature, and the grain size of the nanoparticles is in the range 30 to 40 nanometer from the histogram of this same. The next one is the energy dispersive spectroscopy analysis. From this graph, it shows that it provides the information about the presence and existence of the all elements in material with no impurity. That is, the elemental composition of material is confirmed from ADS. The next one is the TGA, that is thermogravimetric analysis, it detects the thermal stability of the product. And that is from this graph, it has been shown that the synthesized material is thermally stable at 69% temperature. Then magnetic study. As the concentration of a doping element increases, the magnetization of this material decreases. Then application. This prepared synthesized catalyst was used as a photocatalyst for the degradation of methyl orange dye. It degraded methyl orange dye completely in 180 minutes, and the shows degradation efficiency is 77.76%. This graph shows the methyl orange degradation in 180 minutes. Then conclusion. The prepared nanomaterial was synthesized by using a sol-gel method. Then the synthesized nanomaterial were characterized by various techniques such as UV visible spectroscopy, XRD, SEM, EDS, TGA, and VSM. The maximum absorption occurs at 265 nanometer, which has an optical band gap of 1.89 to 2.60 electron volt. From XRD, by using the Becherer equation, the particle size of the nanoparticles is found to be 19 to 27 nanometer, and the material is crystalline in nature and shows FCC structure. Then, from the same image, confirm the formation of uniform spherical structural morphology in synthesized material, and EDS analysis was used to verify the elemental composition purity. And this prepared nanomaterial is used as a photocatalyst, that is, it degraded methyl orange dye in 180 minutes and shows the maximum absorption at 483 nanometer. Thank you, sir.
Hello, Bhosle. You listening?
Yes, sir.
You prepare your sample by sol-gel method, okay?
Yes, sir.
After that, you calcinated for 1000 degrees centigrade, okay?
Sir. Yes, sir.
What is your calcination temperature?
1000 degrees Celsius, sir.
Okay. But from TGA graph, please show your TGA graph here.
TGA? TGA. Yes, sir.
In this TGA graph, the calcination, which is the calcination temperature?
Yes, sir.
From TGA graph, you analyze your sample by TGA, okay?
Okay, sir.
What is your temperature of calcination from TGA graph?
See, from this TGA graph, the temperature, we are getting 4 steps of decomposition.
Sir. Yes, sir.
And after around about 1250, the temperature remains constant. Means around 1250, the decomposition is completed as per my knowledge. So what will be the sintering temperature then?
No idea, sir.
And okay, do you know for what these 4 steps belongs? First, second, third, fourth. First 13%, 32%, 48%, and 69% opposite. So
Sir,
which part is decomposed during these 4 steps?
Sir, in the first step, up to 400 degrees Celsius, there is a loss of water moieties present in the sample. And
up to
yes,
400 molecules. So water molecule does not remain after 200 degrees Celsius.
It is your TJ graph, it is analyzed or manipulated? It is actually manipulated maybe.
See, even water of crystallization goes below 100, up to 100 degrees Celsius. Water of crystallization goes up to 200 degrees Celsius. Thereafter, no water molecules remain in the compound. But you are showing that water molecule is lost around 400, around 500 something temperature. At this temperature, no water molecules will remain. So please check this.
Okay. Yes, sir. Yes.
Something wrong with this deep thermogravimetric analysis. Whether your interpretation or you are seeing something. So from this graph, we observe that decomposition pattern is different than what you are saying here.
It is not actual your decomposition pattern. Okay. Thank you. Who is the next presenter?
Yes, sir.
Hello, sir.
Yes, sir.
NH Ondagar.
43, sir.
39.
NH
Chondagar.
Yes, sir.
Can you hear us? Chondagar? Can you hear me? Introduce yourself. Chondagar, do you?
Hello.
Yes,
May I start, sir?
Yes, you can start now.
Okay. Myself, NH Ondagar. I am doing PhD at Department of Physics, Maharashtra University, under the guidance of Dr. P.S. Solanki. And the title of this presentation is Structural and Electrical Property of LNMO and ZNO composite. So our aim is to modify the property of ZNO and LNMO, and that's why the ZNO was LNMO, which is sodium doped LMO, which is prepared using the sol gel method, and which is the nanoscale size. So our aim is to mix the property of both. Okay, so this is the root of sol gel method, in which the acetate precursor were used, in which the La acetate, sodium acetate, and Mn acetate are mixed in distilled water and acetic acid. Then after the stirring using the hot plate, and we prepared the LNMO, and in different stoichiometry we add the LNMO in 70%, 80%, and 90% in ZNO micro state, and the calcination provided was 700 degrees centigrade. Sintering temperature was 1200 degrees centigrade, and composite sintering temperature was 500 centigrade temperature. So this is the XRD graph, in which the star shows the LNMO part, and hash shows the ZNO part. So which shows the no any detectable impurity in the XRD patterns, and the XRD patterns was fitted using the Ritwell analysis, which shows the parameter in below table. So this very well fitted graphs. To understand the electrical property, the dielectric constant was recorded with the with frequency from 20 to 20 megahertz, and which is fitted using the Cole-Cole relaxation model. And the parameter from the relaxation model shows the relaxation time distribution and relaxation time. So as we saw in this graph, as in individual graph, as we increase the frequency, the dielectric constant decreases, which shows that as the frequency increase, the dipole do not have sufficient time to align with the electric field. That's why it's dielectric constant decreasing. But as the LNMO part increasing, the dielectric constant is decreasing, because we know that the LNMO is the conductive nature due to the Zener double exchange between the Mn+3 and Ms+4. That's why as we increase the content of LNMO, the composite shows the decrease in dielectric nature, and the LNMO shows the negative resistance, negative dielectric constant, which shows the LNMO has the pure conductive nature. And to understand the relaxation model, the UDR model, universal dielectric response also recorded, and which shows that as we increase the content of LNMO, the slope is decreases, which shows the dielectric constant is decreasing. And this is the conductivity, which also shows that as we increase the LNMO content in ZNMO, so our expectation is to settle the LNMO nanoparticle in ZNO micro particles. So that's why the LNMO settle in the grain boundary, which is provide the conductive nature in ZNO. That's why as we increase the LNMO content, the composite shows the decreasing in conductivity, and resistance also shows that as we increase the LNMO content in ZNO, the resistivity is decreasing due to the conductive nature of LNMO. And we also fitted the Siemens model in the conductivity nature, which shows that the LNMO has the CBH mechanism, and also the ZL70 shows the CBH mechanism. Because of the LNM, as we increase the LNMO content in the ZNO, which shows the Maxwell-Wagner mechanism. Thank you, sir.
Okay.
Hello, you listening me?
Yes, sir.
Which are the applications or uses of your samples?
Sir, our expectation is to, as we use this ZNO as a dielectric material in capacitor or like that, so we have to add the prepare the material which give us the lower the dielectric and also moderate level of dielectric and conductivity as well. So this is the trial version. We not expected it for application purpose, but we have to just see the property of composite. That's why, sir.
Okay. Any questions regarding from this presentation?
Thank you.
You have selected ZNO.
Yes, sir.
Instead of ZNO, which compound can be used for work?
Sir, we can use any dielectric or higher insulating material as a CDO. Like CDO is also insulating material, or LMO is also insulating material. So in the place of ZNO, we can use any other material such as the metal oxide.
What is the reason why you can use ZNO or cadmium? You said cadmium.
Sir, ZNO is a high insulating in nature. So if we, sorry,
cadmium, calcium,
CDO, sir.
CDO,
Because sir, ZNO is a higher insulating material than CDO. So if we use the CDO in the place of ZNO, that it will reduce the dielectric in very large manner. So we have to just modify the dielectric nature. So reduce the small amount of dielectric nature, not the much. So otherwise it will be behave like a conductor, conducting nature.
Can you compare the ionic radii of ZNO, CDO?
No, sir. No, sir.
Because ionic radii are mostly identical. So that's why you can replace such ZNO by CDO.
Yes, sir. By structural distortion, it will not affect, but by the resistivity and dielectric, CDO will give the less result compared to ZNO.
Okay. Okay. Thank you.
Okay, sir. Thank you.
Hello. Hello.
Yes. Yes. Yes.
No, any question? I am the next participant. Yes.
Please.
Okay.
OP number?
43, sir. Puse Santosh. Can I start share to my screen?
Yes, you can. Good.
So you can share now your screen.
Yes, sir. I can Sir, PPTs are all visible. Hello.
Yes, it
Hello,
is.
you are
You can
Myself,
yes.
can I
So
start, sir?
you can enlarge this one full screen.
Yes. This is full.
This is not full screen.
This is not a full screen.
okay.
There is a I can sharing. Okay.
You can tilt this one.
On these details. Okay, sir. Okay.
Okay, go ahead.
Okay. Myself, Puse Santosh Arjun. I am from ASA College, Badnapur. So my presentation topic is multi-component green synthesis of 1,4-diiodopyridine synthesis by using the some nano catalyst. So in my scope of presentation, I have an introduction. What is nanotechnology and what is a nanoscale? What are some nanomaterials and what is a catalyst? And why we use a nano catalyst for these organic transformations?
Mr. Puse,
Yes, sir.
you can rotate this screen.
Okay, sir. Okay.
So
introduction in heterocycles are the very important scaffolds for the industrial and pharmaceutical companies or in medicine or the human beings. So these all heterocycles are prepared in a wide range or in a major quantity. So by the for the synthesis of these all green heterocycles, so there is a lot of uh, pollution is done. So all the synthesis is done shifting toward the use of the greener way of the synthesis. So for this greener way, nanocatalyst it is also the important way. Catalyst is the use for this synthesis. Then what is nanotechnology? Nanotechnology means all the materials we can uh, from the size that is nanometer in nanometer scale. So all the materials used for in nano scale. So we can use the in the nano catalyst size. So for the comparison of this nanoscale, we can say that a meter, 1 meter, it is up to the our one hand. Millimeter is 1,000 of the meter. Micron is so like this. The nanometer is 1 billion of the 1 billion nanometers in the meter. So we can say that in 1 meter there is 1 billion nanometer scale is present. So these are the some pictures of this nanomaterial, that is a dots or the graphene material. So then we can see that what is the catalyst? The catalyst is the compound that speed up the rate of the reaction. So this the rate of reaction increases, but it doesn't take part in the reaction. Okay, sir. So these are homogeneous
this is
catalysts.
all note in introduction and
Sir,
everything.
sir, yes,
No.
sir. So
You show
there.
your work. This is all not needed. What you have done that you have to present here.
Sir, I have synthesized 1,4-diiodopyridine, but this catalyst it is already reported. I have synthesized iron magnetic nanoparticles, and they are coated with arginine, that is amino acids, and these again coated with nickel nanoparticles. I have sent all the samples to the lab, but I doesn't get data of XRD, TEM, and the IR. So it is not possible to include in this presentation. But so my scheme of or the I have synthesized 1,4-diiodopyridines by using aromatic aldehydes, ethyl acetoacetate, and the ammonia. And the conclusions. So in conclusions, we can see that these nanocatalysts have the lot of scope. We can modify or the surface or the we can attach the functional groups which increase the acidity or the basicity of the catalyst, and so it is possible for the catalyst to increase the rate of the reaction. So we get or there is a reduce in the reaction times also, and there is a reduction in the pollution of the reactions also. Thank you, sir.
I have one.
Yes, sir. Yes, sir.
You have shown presentation. You have
Yes, sir.
synthesized the compound, but
Yes,
you are
sir.
not characterized. How you can say that the compound is formed without characterization?
No,
And
sir.
how
This is my scheme only. This catalyst
you
is
are not
already
you are not doing
already
any
reported.
experimental work. You are not doing experimental work.
I have done experimental work, but I have sent samples to the characterization, but not get my XRD or the STEM data to add in presentation.
So without this data, XRD and all those characterization, how you can say that your compound is formed and it is used as a catalyst, it can be best catalyst. You cannot confirm without characterization. What? So you
No,
only
no, sir. This is not I have synthesized catalyst. Catalyst I have told you earlier, but this is my scheme. I have to synthesize a new catalyst, but I doesn't get the same or same data to add this the presentation, sir. So I have only the add one review type or the literature type of this the same paper. So can I explain my idea?
what is expected is what work
Yes,
you
sir.
have
Yes.
done, what
Yes,
are
sir.
your
Yes, sir.
needs.
Yes,
That
sir.
is
Yes, sir.
expected here.
Oh, okay, sir. I know. I understand, sir. Okay.
Okay, fine.
Okay, sir. Okay. Thank you, sir.
Okay. Next presenter.
Okay, sir.
OP44. PG Patil. Are you ready?
OP44.
Okay. Next presenter. I invite Rajni R. OP45. Rajni R. Dharamkar. Next, Rohini Dharamkar, OP46. Next presenter, Rohini Dharamkar, OP46.
I think she is not present. Okay. Those who are
Next,
present. Next.
VA Gaikwad, OP48. VA Gaikwad.
Yes, sir, I am present.
Yeah. What's your number?
48.
48, sir.
Okay, start.
Okay, sir. My screen is visible, sir.
Have you shared your screen?
Yes, sir. Just 1 minute.
Not visible.
There is visible my screen, sir.
Yes, it's visible.
Yes, sir. Myself, Vandana Arjun Gaikwad. I am a research student from Dr. Babasaheb Ambedkar Marathwada University, subcampus Dharashiv.
You start from first slide.
Yes, sir.
Yes.
My presentation title is Structural Influence on the Antimicrobial Activities of TeO2 Doped on Iron Borophosphate Glass Material.
Vandana.
Yes,
see,
sir.
You make full screen.
Okay, sir.
You go to slideshow.
Okay, sir.
Yes. Now continue.
Yes, sir. Borophosphate glass materials by the Solgel route. Then this is the abstract. Next we see the introduction. In the introduction, borophosphate glasses have a lot of attention from researchers due to their greater chemical resistance than the majority of silicate and borosilicate glasses. The remarkable chemical resistance of iron phosphate glasses is well recognized. Due to their excellent chemical durability, corrosion resistance, the iron phosphate glasses have proven to be ideal for vitrifying high-level nuclear waste. Pure amorphous phosphate and borate tetrahedral joined by covalent bridging oxygen, whereas pure amorphous borate glasses are made up of trigonal BO3 group. The phosphate and borate modifier content may increase bioactivity and the need for biomaterials made of biomedical glass fibers. The sol-gel technology was used to manufacture the glass in order to more effectively dissolve the greatest amount of doping in it. Then we see the synthesis. For the synthesis, taking a mixture of ferric nitrate, boric acid, ammonium hydrogen orthophosphate, and telluric acid in a 250 ml beaker. Then the reaction was stirred at room temperature for 1 hour while maintaining the pH acidic. Then the reaction was heated at 80 to 90 degree temperature for 2 hours. After 2 hours, gel was formed in the reaction. Then continue the heating up to getting the powder. After 2 to 3 hours, heating, the yellowish colored product was formed in powder form. Then the synthesized glass material was calcinated at 650 degree temperature for 6 hours. Then I was taken the characterization. In the characterization, first we see the thermogravimetric analysis. The weight percent loss is calculated by using thermogravimetric analysis. In the thermogravimetric analysis, there are the 3 steps are observed for the weight percent loss. In the first step, 0.75% weight loss is observed in between 30 to 200 degree Celsius temperature. Then, due to the evaporation of residual trapped water. Then in the second step, 0.53% weight loss is occurred in between the 200 to 300 degrees Celsius temperature due to the volatilization or residual oxidation. Then in the third step, 2.93% weight loss is occurred due to the formation of FeO in between the temperature 300 to 650, while 650 to 900 range shows the formation of stable oxides. Then we see the UV visible spectroscopy. In the UV visible spectrum, the maximum absorption peak is observed at 302.07 nanometer and the optical band gap is calculated at 4.97, 4.95 and 4.94 electron volt. Then we see the X-ray diffraction. This is the combined graph of 3 reactions at different concentrations. In the powder XRD analysis, by using Debye-Scherrer equation, the particle size is calculated. For a reaction, first is 9.77, then for the second reaction is 24.28, and for third reaction, particle size is 26.68 nanometer. With the help of VHKL plane, it can show the base-centered cubic crystal structure. Then the interplanar distance, lattice constant, volume, X-ray density, and Hooping length of octahedral and tetrahedral sites is calculated as shown in the following table. Then we see the scanning electron microscopy. In the scanning electron microscopy, all same images shows the chorus and porous similar morphological structure. But the image first is little chorus and porous than that of the other 2 images. According to the study of XRD, X-ray diffraction study, the particle size is calculated less than 100 nanometer and it is confirmed by the size of same images. Same images shows the size less than 100 nanometer. Then we see the elemental detection analysis. In the elemental detection analysis, there is the presence of boron, iron, oxygen, phosphorus, and tellurium is present. There is the no any other peak is present in the EDS. Hence, it can shows the purity of sample. Next, we see the dielectric constant. According to dielectric study, the dielectric constant and dielectric loss tangent gradually decreases with increasing frequency, and the conductivity of synthesized glass material is increases as the doping of TeO2 concentration is increases. Then we see the antimicrobial activity. These compounds show the antimicrobial activity against both gram-positive and gram-negative bacterial and fungal pathogen. Then, however, the antimicrobial activity was more against fungi, Aspergillus niger and Candida albicans as compared to bacteria, indicating its potential use against fungal pathogenic infection. A minimum inhibitory concentration test was performed for all 3 compounds as per the method and guidelines of the Clinical and Laboratory Standard Institute. This is the application. Then this is the graph for antimicrobial activity of glass material against different pathogens. Then we see the conclusion. In the conclusion, borophosphate glass material was successfully synthesized by using Sol-Gel technique. Then in the UV visible spectrum, maximum absorption occurs at 302.907 nanometer and optical band gap is 4.97 to 4.94 electron volt. According to XRD, it can show the base-centered cubic crystal structure and particle size is observed in between 10 to 13 nanometer range. According to FECM analysis, glass material shows porous and porous morphological structure. The EDS analysis used for elemental detection. Then, according to dielectric study, the dielectric constant and dielectric loss tangent gradually decreases with increasing frequency. That means conductivity is checked by the dielectric study. It shows the antimicrobial activity against different types of bacteria. These are the some references. Thank you, sir.
You go to your microbial studies slide. Microbial studies.
Yes, sir. 1 minute.
Head. Last one.
Okay.
You go. Yes.
Yes, sir.
You go to the slide number 12, 11.
11. Okay.
Dielectric study. And 12th one is microbial.
Yes, sir.
I want to know, you have used gram positive and gram negative bacteria for
Yes, sir.
Microbial studies.
Yes, sir.
Did you compare the results of gram positive, gram negative bacteria of your product with standard one?
Yes, sir. I was compared the results.
Which standard you used?
Here are the standards.
Which standard you have used for comparison of results?
1 minute, sir. Bacillus subtilis.
Is it a fungus or bacterial or fungal study?
1 minute, sir.
There is difference between bacteria and fungi.
Yes, sir. There is the difference between bacteria and fungi. Some bacteria inhibits the my catalyst inhibits some bacteria and inhibits some fungal pathogens.
You have written here, you can see Candida,
Aspergillus.
Yes.
Aspergillus niger, it is the fungi, and Candida albicans, it is a bacteria.
Okay. You have compared your compound results with these two.
Yes, sir.
Okay. What do you find from the results? Whether they are
yes, I have found my synthesized material inhibits some bacteria and inhibits some fungi.
can they can be applied for medicinal purposes if they are biologically active? Can we
Yes,
apply
sir, in future.
Okay, no problem.
I will try.
Okay, thank you.
Hello.
Okay, thank you, sir.
Hello, ma'am. Are you getting my noise? Hello.
Yes, hello.
How you can maintain temperature as 80 to 90 degree for the preparation of glass?
With the help of TGA, sir.
TGA? You are performing the experiment and immediately you are considering TGA. How is it possible?
Sir, I can't understand the question. Please repeat it.
Or the preparation of a glass, you are maintaining temperature as 80 to 90 for
80 to 90 degree. Yes, sir. 80 to 90 degree.
How you can maintain?
With the help of thermometer.
Method is adopted.
By the Sol-Gel method, sir.
Okay. Tell me another thing. Glass is super cold liquid.
Yes, sir.
How saying that it is having the crystal structure?
It can show the crystal. Glass is of two forms, amorphous and crystalline.
Amorphous and crystalline.
Yes, sir.
So your product is whether crystalline or amorphous?
Yes, sir. My product is a crystalline glass material.
Which is the structure you assign to your product?
Base-centered cubic crystal structure.
How you decided? How did you decided these structures?
With the help of HKL plane study.
Okay, thank you.
Okay, sir. Thank you, sir.
Okay, thank you. Next presenter, Hardika Goswami. Hardika Goswami.
Whether Hardika Goswami is present here?
Sir,
I think she is not present.
Hello, sir. Can I present my presentation as I talked to you earlier?
Your name and number?
My name is Ashwini Malkhare.
Number?
My name is not in the list, sir, actually.
You have opted for online or offline?
Pardon, sir, please.
You have opted online presentation or offline presentation?
Online presentation, sir.
Yeah, you can. Your name is not in the list.
Yes, sir. My name is not in the list.
Okay, you are registered, no?
Yes, sir. I have registered.
And you can present.
Okay, thank you, sir. I am presenting from Gaikwad Madam's laptop. Thank you.
You introduce yourself and you can start sharing and present.
Yes, sir. Yes, sir. Yes. Good afternoon, everyone. Today, I am presenting my research proposal on novel synthesis of nano-size mixed metal oxides.
Ma'am, 1 minute.
Okay, sir.
Ma'am, 1 minute.
Okay,
Loa,
sir.
Loa, sir, आवाज येतोय का?
Yes,
Hello?
I am. Yes,
Sir,
I am.
आता हे जे नाही आहेत लिस्ट मध्ये त्याची नाव लिहून घ्या आणि मग आपण अलाउ करू.
Okay, sir.
Just continue, ma'am.
Okay, sir. Thank you, sir. So, good afternoon, one and all. I am presenting my presentation on novel synthesis of nano-size mixed metal oxides with their structural properties. And myself, Malkhare Ashwini Anil, I am a research scholar, and I am presenting this under the guidance of Dr. Somavanshi Madam. So this is the outline, that is introduction, my practical work, result and discussion, some literature review, and the acknowledgement. First of all, I would like to say some information about my mixed metal oxides, that is, the metal mixed oxides nanomaterials represent a growing asset in many industries. The industries, especially with their heightened chemical, physical, and electronic properties compared with their bulk counterparts. And these metal oxide nanomaterials are versatile materials. We can use it, or we can give the application of such materials in the environmental remediation, medical technology, energy, water treatment, and personal care products. So also I would like to say some information about my synthesis process. As we know, there are several methods such as co-precipitation, hydrothermal synthesis, Sol-Gel, and the microwave method. These are used for the preparation under various and the moderate conditions. But I am here choosing the sol gel method. Some points are there behind it. Why I have choose this? Because the advantage of sol gel method includes high yield, low operational temperatures, and the low production cost. So, the produced nanomaterial or the nanoparticles applying the sol gel method have exhibited high purity and desirable chemical homogeneity, and which is most important. And these synthesis of various kinds of ferrites and investigation of their structural, chemical, and the physical properties are still interesting research area. So let's get into the objective. The first is preparation and the characterization. So this is the important part of the synthesis. Firstly, I have taken the nitrates of the silver, nickel, magnesium, and the iron. I have taken this with the citric acid. Then stirred it for half an hour. It all get dissolved. I have maintained the pH neutral at 7. After that, I have given the continuous stirring at 80 degrees Celsius with the help of thermometer. I have maintained the temperature. I got the formation of gel. After the gel formation, there is a crude product. I have cooled it at room temperature. After that, cooling that temperature, I have calculated it at 500 degrees Celsius for the 7 hours. Here, the most important point is about the calcination. I have taken this temperature, that is 500 degrees Celsius, with the help of the characterization, that is TGA, because I have got my thermal analysis. From that, at the first stage, there is removal of water molecule up to 30 to 150 degrees Celsius. After that, some inorganic materials are there which get removal at the 150 to 350 degrees Celsius. After that, up to the 350 to another 600 degrees Celsius or up to the 500 degrees Celsius, there is a removal of excess of ammonia. Why ammonia? Because I have added it with in the synthesis for my pH. So it got removal and I got the thermal stability, that is up to 83%. So this is the thermal analysis. After that, the most important characterization is the XRD for the crystalline size and for the crystal structure. So this is my XRD pattern of magnesium doped silver nickel ferrites nanoparticles at different concentration. And according to this XRD, I got the average crystalline size is between 18 to 23 nanometer. And by Debye-Scherrer equation, I got the crystal structure, that is body center cubic structure, that is BCC. So this is my XRD pattern. The next characterization is the scaling electron microscopy. And I got this, the chorus and porous structure. I got the morphology by this. Now, I want to conclude my presentation. In the present work, I studied the magnesium doped silver nickel ferrites nanoparticles via sol gel method. The XRD pattern gives the BCC structure and the crystalline size 18 to 23 nanometer. After that, TGA is study for the thermal properties. And by the same, I got the morphological structure. Yes, there are some applications of my synthesized product in the antimicrobial and in the photocatalytic reaction. So these are some references and I would like to thank you for giving such a chance. Thank you.
You go to your DTA TGA.
Okay, sir.
TGA graph.
Okay, sir.
Yes, you show that. So here you are observing 2 points of decomposition.
Yes,
First
sir.
one around 100.
Yes, 30 to 150, sir.
Yeah. Is it exothermic or endothermic weight loss? You are seeing the 2 weight losses here.
Yes.
Around 150.
Yes,
And then
sir.
it is above 400. So at 150, you are observing one peak, whether it is exothermic weight loss or endothermic weight loss.
Actually, sir, it is a endothermic.
Endothermic. Why it is called endothermic then? Okay. Which moiety is lost at the temperature of 150 degrees Celsius? Here in this
Some
inner
loss
compound.
of the physioadsorbent, like some water loss is there.
How many water molecules are there?
Sorry, sir.
How many? You have not shown the weight loss here. Actually, you could have shown weight loss.
Yes, yes, sir. At the first step, I got the 35% of weight loss.
And
then at the first step, 3.5%. After that, at the second step, 11.5%. And after that, 2%.
Okay, 3.5% of weight loss correspond to which moiety? Which is the moiety that is lost corresponding to 3.5%? Can you mention here?
The 3.5% loss is about the water, sir.
How
I
many
have
water
not mentioned here.
How many water molecules? Roughly
I
how
have
many?
not calculated, sir, actually. How
You
many
should
water
calculate. You must know.
Yes, sir.
Molecules, what should be the appropriate percentage? For 2 water molecules, what should be appropriate percentage?
Yes,
Okay.
sir.
Go ahead.
Yeah. Hello, sir.
Sir.
I have one more question. Hello, you listening me?
Yes, sir. Yes, sir.
What is your calcination temperature?
Yes, my calcination temperature is, sir, 500.
Yes, okay. Please show your TGA graph.
Yes, sir.
From where is the 500 temperature? At 500 temperature, you see your okay.
Yes, sir.
There is some weight loss. Okay.
Yes, sir.
Up to 800, there is the graph is to be decreasing.
Yes.
How you identified your calcination temperature is to be 500?
Because, sir, at 500 degrees Celsius, my graph is going to be stable. There is no loss.
Stable. Your graph at up to 800, there is no stable. It is to be decreasing order. Okay.
Okay, sir.
How you identified 500? At 500 degree, there is a somewhat decline position. Okay. After that, there may be a particularly weight loss. It may be in some 2 or 3%. Okay.
Yes, sir.
How you identified it is a calcination temperature?
Because after 500 degrees Celsius, sir, there is a negligible weight loss, and the weight loss of inorganic matter and water is just showing some peaks.
At 500, which is the inorganic matter? Which possibility is there? There is only evolution of you identified what is the sol gel product. I think according to sol gel theory, the final product is to be metal hydroxides. Okay. Yes, at near about at 150 degrees, there is a loss of a coordinated water. After that, some loss, and finally there is a loss of oxygen.
Yes, sir. Oxides.
I think your sample to be used as a catalyst to study. Wish to study?
Sorry, sir.
You prepare your sample, okay? Catalyst.
Yes, sir.
What is your next purpose or application part?
Yes, sir. My next purpose is to give some photocatalytic activities because it is containing silver. So I am having hopes of antimicrobial as well as photocatalytic activities.
Okay, if you study photocatalytic activity,
yes,
your catalyst is homogeneous or heterogeneous?
It is homogeneous, sir.
Homogeneous. Okay. Thank you.
Okay. Thank you, sir. Thank you.
Okay, thank you. Who is the next one?
All are completed, sir.
Will announce whether someone is in. Yes.
Sir, OP17, my remains, sir. Can I continue, sir?
Yes, you can present here. What you tell our-
Introduce.
Myself, VK Raut, sir. Vaibhav Raut. OP 17.
OP17 is another session, first session.
सर ते सेशन नाही आहे
नाही त्यांना अलाउड करू द्या ना सर.
अलाउड करा त्यांना ते सेशन नाही
हो हो करा.
जे राहिलेले आहेत त्यांना अलाउड करू.
हो हो.
Yes, VK Raut.
OP17.
Can continue.
Very good afternoon, sir. Can I present, sir?
Yes, you can share
Sir,
your
due to
screen.
technical issue, I am unable to join yesterday. Yesterday in second session I have joined, but again in second session the chance is given to second session students, so unable to exhibit yesterday, sir.
Okay, no
So
problem. Now you can continue.
okay.
You will be
Sorry
considered.
for that, sir. So very good afternoon to one and all present over here. Myself, Vaibhav Raut. So can I share, sir?
Yes, you can.
Okay. So my topic is in vitro magnetic hyperthermia studies of supermagnetic zinc spinel ferrite nanomaterials, nanoparticles. So this is the subject of my abstract.
Mr. Rao,
Yes, sir.
you have not mentioned your guide's name. You are doing not doing PhD. You are doing PhD or not?
Yes, sir. Research scholar, sir. Under the guidance of Dr. C.T. Birazdar, sir.
You should have mentioned the name.
Sir, actually.
No,
Okay,
it is the acknowledgement. You should mention the names. Okay, continue. You can continue.
To only discuss about the preparation result and conclusion.
Okay, sir. Okay. Just a minute, sir. One minute, sir. Is it getting problem? Sir, there is a problem in sharing, sir. I don't know. 1 minute, sir.
Sharing is allowed. No problem.
Can you able to share? Can you able to see, sir, my screen?
Not yet. Are you sharing?
I'm sharing, but it might be the.
No, here there is no problem. Problem will be on your side.
Yes. Problem is there from my side, sir.
You can try by other way.
1 minute, sir. 1 minute. So can I join again, sir? Can I leave and can I join? Because getting problem is, sir, in sharing. Hello, sir.
Yes, you can.
Sir, can I leave and can I join again? Because
Yes, of course. Offline चालू. Yes, Raut, now you can try. Are you listening, Mr. Raut? Yes, your screen is visible now. You can. Raut, can you hear us?
Yes, sir. Now it is visible, sir.
Yes, now it is well. You can start now.
Yes, sir. Sorry for the interrupt and inconvenience in between, sir.
No problem, no problem.
In vitro magnetic hyperthermia studies of super paramagnetic zinc spinel ferrite nanoparticles. So myself Vaibhav Raut, research scholar under the guidance of Dr. Siti Birazdar, sir. So introduction, that is spinel ferrite. So we know that spinel ferrites are the compound with general chemical formulas.
Hello. You
Yes.
only do your a method of preparation, result and discussion.
Okay, sir. Only abstract have, sir. So by the sol gel method, then you know very well sol gel method means the method we can get the particular nanomaterials by sol gel, viscous gel, then combustion, then grinding, and then afterwards characterization. So the abstract is recently magnetic nanomaterials, in particular spinel ferrite nanoparticles, were emerged as an active nano platform for the biomedical applications due to their easy control and stability, low toxicity, and biocompatibility. So the present work focuses on in vitro magnetic hyperthermia studies of super paramagnetic zinc spinel ferrite nanoparticles. So hyperthermia is the abnormally high body temperature or O rating. So in that super paramagnetic, so it is a form that the magnetism which is appear in a small very ferromagnetic, or we can say ferromagnetic nanoparticles. So as we know that nanoparticles are used in very biomedical applications due to their easy control. So this this is the prepared by the sol gel combustion method. So magnetic hyperthermia has been introduced chemically, as in we know that it is an alternative approach for the treatment of tumors. So the present work focus on this magnetic hyperthermia, and this is it is prepared by the wet chemical sol gel combustion method. So the prepared nanomaterials were well characterized by the standard technique for the structural, morphological, and magnetic and dispersibility investigations. To know the capability of prepared nanoparticles for the effective use in magnetic hyperthermia applications, the in vitro magnetic hyperthermia was performed. So to confirm the non-toxicity of the prepared nanoparticles, the reactive cell viability analysis was performed for the appropriate cell line assay, and the present work outcomes demonstrate that the magnetic hyperthermia therapy induces the significant heat production that is accountable for the killing of cancer cells via cell apoptosis. Because we know that as the targeted drug delivery and magnetic hypothermia and the magnetic, these are the located for the particular area and can be targeted to the particular cancer cells and can kill the particular cancer cells with the help of the nanomaterials. Thank you, sir.
Mr. Raut?
Yes, sir.
Where is your work? This is all theoretical.
Yes, it is abstract, sir.
So what we expect is what you have done, your work, what are your findings, that is to be presented. It's all more theoretical.
Okay, thank you, sir.
Okay.
Who is the next presenter?
No, sir.
No, sir. Sir, now we conclude.
Is there anyone left with the presentation to wish to present? Please inform us. We are going to end the meeting. Okay, Patil sir.
Hi.
Please. no participants are left with presentation. So now we can conclude.
Hey, John, Uday, John.
Lower sir.
Yes, sir.
Conclude kara. Vote of thanks, madam. Conclude.
In these sessions, about 11 participants give their oral presentation. Among them, some participant give very nicely represent their concept.
सर आवाज येतोय? हॅलो, तुमचा आवाज येत नाही सर.
हा, आता hello.
हा, येतोय आता.
In these sessions, about 11 participants give their presentations. Among them, few participants present their research work very nicely, and those participants having their clear idea about their own work. I congratulate those participants, but we observe some participants, they represent their work very poorly. I suggested those participants, if they are wish to complete their research, they initially go through reference and clear their idea concept regarding the research. I congratulate participants, give their fine and nice presentations. With my concluding remark, I here conclude this session. Thank you.
Okay, Patil sir. Shall we conclude?
Yes, sir. Good afternoon.
Good afternoon to everyone. Yes.
My sincere thanks to the Dr. Kulkarni sir, Principal of Shrikrishna Mahavidyalaya Gunjoti, who spared time from his busy schedule to grace the occasion. I thank to Chairperson Professor Dr. K.S. Lohar sir, Shrikrishna Mahavidyalaya Gunjoti. I also thanks to all the participants for their valuable contribution to the event. Now I declare that this session is over. Thank you. Thank you.
I congratulate all the participants, resource persons, examiners, chairperson, coordinator Narendra Patil sir, and our beloved member of management, Ibati sir, who is present here for the entire session. For this session, I thank once again all the participants and resource person. Now we are going to end. Now I will conclude. I will end the meeting with the permission of all. Thank you. Thank you all.
Thank you.
Recording stopped.